Hello friends, welcome to my channel, You and Me at Pharma. Today I am here with a small topic. Yes, that's called chelating agents. So let's learn something about the chelating agents. So what does the chelating agent mean? Chel, in Greek it's called crab. So how does just the crab holds any object very strong way? So in the same manner, even this compound chelating agent holds a metal in the strong way. So hence in the Greek it's called as crab, chelating agents. And the agents which form the complexes with metallic ions and thus forms a new structure within themselves. So just they themselves create a new structure inside them once they bind with the metal. And mostly these are used in the heavy metal poisoning, various heavy metal poisonings. So treat this is an easy way to remove the heavy metal poisoning. So let's quickly learn about what are the different types of chelating agents. So first comes the unidentate chelating agent. It means the agent which binds and complexes with only one metal, maybe anything. So that is a unidentate. Next, bidentate or polydentate. So this it means that it forms a complex with two or more metals. So hence it's also called bi or polydentate. Next is the sequestering agent. This is somewhat important, generally which is soluble in the water. So we just don't have a more toxic effects of this as they are soluble in water. And so this is meaning of a sequestering agent. Let's see the different types of complexing agents. So first comes is EDTA. Yes, very important example. So EDTA, what does it mean is ethylene diamine tetraacetic acid. So that's the abbreviation of EDTA, and it is the sequestering agent, one of the sequestering agent we have learned already, and which is sparingly soluble in water. We generally use the disodium editate form of EDTA, not as itself the EDTA we can't use. So we generally use the disodium editate by treating with NaOH because it has a flexibility of having 4 pKa values, and also it's less toxic when we use in this manner. So that's the reason we use in disodium editate. So what's the use is mainly it's a chelator for calcium. It's a good property to which acts as an antidote for calcium. That comes as the EDTA part. So next learn is dimercaprol. So what does this mean? So let me say you a small story of this compound behind this. So what this? Generally during the World War II, Britishers developed this compound mostly as an antidote to an arsenic gas form called as levisite. So levisite is an arsenical gas form. So to that, Britishers developed this dimercaprol as an antidote, and so that's the reason behind it's called as British anti-levisite, also called BAL. And according to the structure, it has two sulfhydryl groups and one hydroxyl group in its compound, in its main structure. So hence it's called, as it has two sulfhydryl groups, it's called dimercap, and it has one hydroxyl group, it's called ol, as we denote anything in IUPAC as ol, hydroxy group. So that's the reason behind its name, dimercaprol, shortly called as BAL. So mostly it is used in the poisoning of mercury poisoning, arsenic and bismuth and many, maybe lead, etc. many things. So most favorably used antidote. So this is about the dimercaprol. Then next comes is also an important one, desferoxamine. So this is the one. Let's learn the meaning first. Ferroxamine. So what is the ferroxamine? It means like iron containing chain. Ferri means iron. So iron containing chain is called as ferroxamine. So if what this des means? Means any group if it is removed, so that removal process is called as des. We also can name it as nor, but in this case we deal it as des. So removal of an iron from its chain is called as deferoxamine. So it's a compound without iron now. So generally it is obtained from actinomycetes. So that's its origin. And what it does is it just winds up to the iron and it forms a chelate with that, and thus it removes the iron from the material or the body. Generally, it is used in iron poisoning, severe iron poisoning. We use this deferoxamine. Next, transfusion siderosis. So, what does this mean? Generally, in the overloading of the iron, whenever overloading of iron occurs in the body, so this deferoxamine is used so that it drives away the iron from the body. So that's a use of deferoxamine. Next comes is penicillamine. Even this is too important. So generally, it is a degradation product of penicillin. We know penicillin is an antimicrobial agent which is used mostly, and so from that penicillin only the degraded product is called as penicillamine. And the structure part is dimethylcysteine. It includes dimethylcysteine group in it. And mostly among D and L isomers, we generally consider and mostly use the D isomer because of its easiness, like to use it. And its use is mainly copper poisoning, Wilson's disease, mercury, and cystine stone. So it is used in all these cases. So let me tell you what is this Wilson disease. Generally, in our body, everything is being regulated in a controlled way. So in the copper, even the copper when it gets excised, so that will be removed by a compound in our body. So that is actually called as ceruloplasmin. So it's a protein which is in our body to remove the excess copper. It just binds and chelates with the excess copper and it just removes it, drives away from our body. So when this ceruloplasmin protein is deficient in the body, so then copper cannot be driven out. So to drive the copper out, so we need an antidote for it. So that's the penicillamine we can use as an antidote for Wilson's disease as it drives out the excess copper from the body. So this is all about penicillamine. Next, last but not least, that is succimer. So what this succimer is, its full form is actually dimercaptosuccinic acid in its structure. So that's the structure part. And it is same as that of the dimercaprol, but the thing is it is less toxic and also water soluble. So generally this makes it easy to use, and also it is used in arsenic, mercury, lead poisoning, etc. So this is the role of succimer. So this is all about the chelating agents, friends. Thank you.